So the information on the top there is what's given. In green, what you see is the definition of the dot product. Okay? You've got the magnitude of vector A times the magnitude of vector B times the cosine of the angle between them. When you multiply those three numbers together, you get the dot product of the two. And we have all the numbers, so all we have to do is fill them in. 30 times 25 times whatever the cosine of 37 is. Bring out the trusty calculator and find that it's 0.8. And let's put that down as 8/10, because that makes it easier to do the arithmetic. You just cancel, multiply, then multiply again, and 600 is the answer. So 600 is basically, at least roughly, the dot product of A and B. Starting again here, we've got the definition of the dot product. This problem's a little bit different because they give us the magnitudes, right? And they give us the dot product, but they don't give us theta. But that's okay. We can still figure that out. We could divide both sides by 600 and get 1/6. Then take the inverse cosine of 1/6, and whatever that is will be theta. And, oh, by the way, it's about 80.5 degrees. I got that answer from the back of the book, but just to make sure it was right, I plugged it in here, took the cosine, and there it was. This is the next problem. I've got two vectors in component form. With the three-dimensional vectors, we have a different technique for finding the dot product. We multiply the coefficients and then add them. Now, can find the magnitudes of them and know that when we multiply them together and then the cosine of theta, that'll equal 21 because that's the dot product, and that's the definition of dot product. So now what we need to do is find the magnitude of A, and we do that by the three-dimensional Pythagorean theorem. Take the coefficients, square them, add them, take the square root of that, and do the same thing for the other one. It's this, you get a secret number that I'm not going to show you. It's actually 66, square root of 66. Now we've got all the numbers we need to make this work. We can put in the square root of 38 here, put in the square root of 66 here, and multiply that by the cosine. Now what we really need, of course, is the theta, so we've got to take 38 times 66, take the square root of that. 21 is equal to 50.08 times the cosine of theta. Divide both sides by 50.08, and so that's going to be the cosine of theta. Take the inverse cosine of 0.42. The inverse cosine of 0.42 is about 65.2. This one's the more interesting problem, and this is my primitive, crude drawing here. We've got the x, y, z axes and two lines that are tied to a sail and secured on the deck of the cabin. The y-axis is the one that goes forward to back. It gives you the forward direction of the ship. The x-axis goes across the bow of the ship, gives you the back and forth turn. The z-axis goes straight up, and that's the force that's actually pulling, basically pulling the cleat out of the deck. So now, in order to find out the effect that those two ropes are having together, we add the vectors. And you do that by adding the components, and that's what you get. The series of questions that comes next is, what is the force pulling the boat forward? And that's your j-axis. So that's 120 pounds. There's 120 pounds pulling your boat forward. What's causing your boat to rock side to side? You've got 45 pounds of energy doing that. And what's pulling up on the cleat? About 15 pounds. Okay. You know, all together, how much force is there? And again, that's a job for the three-dimensional Pythagorean theorem. and a calculator. That's the answer we get. It's about 129 pounds, the total of the force on the boat. The next question was kind of bizarre because it wanted to know, okay, well, what about the magnitudes of the individual vectors? If we added that together, would we get the same answer? Well, we already know that we're not going to get the same answer, but since we're going to need the individual magnitudes anyway later, I figured, okay, let's just calculate them then. Okay. Calculating the first one, and that's 72.3 pounds. Now we do the other one. Same deal. We take the coefficients, square them, add them together, take the square root. And we get about 58.5 pounds. Now we add them together, we get 130.8, and that's not the same as 129. So the answer to the question is no. Now, the thing is the dot product, you multiply the two magnitudes together times the cosine of the angle between them. We actually can get the dot product in a fairly straightforward way. We multiply 15 times 30, 70 times 50, and 10 times 5, and then add them together and get 4,000. That's our dot product. Now, we just figured out what the magnitudes here were. This was 72.3, and this one was 58.5, and this is the thing we don't know. But now we have some simple arithmetic to do in order to figure it out. And we get 0.95, sort of. And that is approximately the cosine of theta. Now we take the inverse cosine of 0.95, about 19 degrees. Well, that's the angle between them.